All right, it's on. So hello, everyone. Welcome to this session, the final milestone presentation of Zero Knowledge project, which Mahmoud has been working on, which is zkRegEx. So Mahmoud, stage is yours.
Okay, thank you, Rish. Yes, so let's start with zkRegEx and ONJS. And first of all, let me start with the README. So zkRegEx and ONJS is a compiler and also now a CLI tool to compile regex circuits in ONJS. And in this month, I've been working on this for, I think, March and April from season 1. And here I am wrapping all this with the new features. And as a CLI in season 2, I worked on this in June. So, 1 second. Yes. So zkRegEx and ONJS is used mainly to process text inside circuits. And by the way, there is only one implementation, which is in Circom and also in Halo 2. So this is a new implementation in ONJS, and it's fully functional and it's really fast. So I added to the documentation everything in here, and now how you can use the CLI, how you can install it with different options, and why zkRegEx is important. So mainly this innovation was made for zk email, but it extends over that to any application that needs string processing, and also as I showed here in this month, is that you can use this also to process full field elements. So yeah, I can start. You can install the CLI as a global dependency, which is you can print in here like zkr or zkRegEx. So if I do this, so zkr is like 0.2 version, and have zkRegEx, which is like in here, zkRegEx version. And you can follow all of the steps to do this and use the compiler. So I will start with an explanation that assumes that you are familiar with regex. So, and why regex is important. So I can start, for example, which is, by the way, this is a revolutionary because you're doing this inside the circuit. So if I do zkr, which is the compiler, and I'm just doing, let's say, A and count. So this circuit in here will show you this one. Yes. This one will, if you give it bytes from a string, which is pretty easy, you can do it also in ONJS with the bytes from string API, and you give this an input, then what will this circuit do? It will count and validate every lowercase a alphabetic from that input, which is this is the simplest use case, but this wasn't used before in any other application. But this is like an option called count, but if you just input it like this, you will have this output, which is a Boolean stemmed from here, and this will say that whether this array of bytes you inputted contains an A alphabetic lowercase or not. So this is a small intro on regex, and I can show you here the syntax of how you can compose some complicated regex pattern. Yes, before that, please, I have everything documented in here, starting from how to see the options. So it's with the flag H or help. Yes. So we have here a bunch of options, including count, revealing transitions or subpattern, and function name and file path. So you see, as you can see here, its outputs, let's say, also this is called the alphabetic lowercase pattern, and we have a circuit like here. So before this month of season 2 of Navigators, what you used to need to do is like to copy paste this. And I will show you how it used to be. So if we come here and let's say, so what you need to do is set a function like this and give it a name. It's called new regex, and then paste this. And what you have some errors here because you need to import the modules and you have to do that manually. So basically you need the bool, the field, and the uint8. And uint8 here is important because we are processing bytes, string bytes in particular. Yes. So when you have it like this, you can then also export it and then use it inside your zk app or inside your zk program. You can do a lot of things with it. So this is how to use the CLI. But yeah, I would like now to briefly emphasize on the syntax. Yes. So you have a syntax guide in the README. It contains what's allowed in zkRegEx and O1JS, with also many additions this month that worked on this. So you have the whole support in here, also with some limitations. So for now, most of the support is there, except of the anchors, which really try to validate certain patterns, whether the input starts with a regex pattern or finish it with a rex pattern. But other than that, everything is possible. So let me show you. So we did the A validation here. We had a circuit, but what if I said I want like a full name, let's say. Let's call it Mina, like this. Then this is what's called in here as sequence regex. So, and the regex, what we'll do is take the sequence of bytes and map through the array of bytes and check if Mina lowercase exists in the input. But you will have what is called alteration or number classes or character. So you can do Mina or like Mina like this. Or even you can go even further, like you can choose any pattern. Press enter, and yeah, you have the full pattern written in here.
Sorry, Mohd, I had a question. Is there a
Yes.
limit on the length against which it can check, or it can be unbounded?
Yes. So the more you put into the pattern, the longer the circuit it becomes, and the more constraints it generates. Because as you can see, the longer the circuit, the longer the operation it becomes, and hence, and this is all related to the length of the input. So correlated to that, you have the total number of constraints. But for example, if you have a very complicated, like, or very long pattern, like let's say, and so on and so on, but you have only tried to let's say, the input you have is with 4 characters, let's say. I just want to check that those 4 characters are like Mina lowercase or uppercase, etc. Then it will be a very, very like efficient circuit because the inputs or the length of the input is short. So to give you like more meaning to what I said is that, for example, zk email uses a pattern like, let's call it like here, B64, and then plus, and like this. And the base 64 is mainly, if you are interested, I can show you the full example. So Yes, so it uses so this is the full regex pattern of zk email body hash. See, it's a bit long, but not very long. But the problem is when it's bounded because of the length of the input. This one. Because zk emails requires length from like 1024 to 1536, which makes it a pretty heavy constraint circuit, which is in the scale of, in this case, like 80,000 constraints. And in this situation, you can't really generate proofs with that.
Gotcha. Thanks.
Okay. And so since I showed this example, what we can do is also it's called like concatenation ORing. So you can have a bunch of that. I said Mina, or like, and then, and A, only a single letter, or like, even you can combine this with ranges. I think I need some numbers 0 to 9. By the way, these are like ASCII numbers, not the numbers that that are like, so they are represented differently. So when you have a circuit like this. So okay. So if you don't use the brackets, then you won't really expand. And you see we have 0 to 9 expanded. This is why we have expanded in the terminal. And here, nothing is expanded. So you can make sure to check this out, like whenever you use the compound. So also you can use repetition. So what's repetition is like, for example, I want to check that the pattern is having a sequence like, for example, I have, let's call it ABC, but I want to check with regex that it's repeated 3 times. So I put enter, and you see, it's like curly braces 3 times. It's like the repetition is 3 times. And with this, like you have ABC, ABC, ABC in the same sequence that is represented in the array of bytes in here. By the way, this is a new feature added this month. So you can leverage using this to easily write regex patterns for the compiler. And also, like, you can use it with, like, everything can be composed to write very complicated patterns like this is like, or human, or like 3, 2, 1, and I press enter. I have a huge circuit. See how it is expanded. It's like this. By the way, this is not meaningful, but you can see how powerful it is to write patterns with the syntax support. So a new thing added this month for the syntax is also ranges. So for example, like I have A to Z, lowercase, and I press enter, I get this circuit. So before this month, this used to be hard-coded to A to Z. So, but this is quite limited and annoying, because other than that, you would have to write everything manually with the ORing expression. So what is ORing expressions like A or B or C or D or E, for example. You would enter it like this. But with this new feature, what you can do is, I want A to E. So just enter it like this, A to E. Press enter, you have the circuit, and you have it expanded, as you can see here. This is, for example, in this regex circuit, this means that it's a Boolean validator, because we didn't use the count option. So it says that please return true if you find any of these letters, A, B, C, D, E. Otherwise, it's going to be false. And if we use the count option, for example, in here, we can do it also with the flag C. So what it means is that among these letters, if you find any of these, just count them. So if I have an input, an array that contains AA and DCE, then we have 5 returned as a field here. So see, it returns as a field. also you can combine a bunch of ranges. So I have A to E. I need numbers 5 to 9, for example. And I can use also uppercase letters. I need some F to X, and I press enter, and I have it expanded in here. And I have the full regex pattern as explained before. And also you can combine single characters inside of the brackets if you need. So you can underscore. I can do, let's say, this symbol. Press enter. I have it entered. This is so. Yeah, this is with the syntax support. And what's also amazing with the compilers that you can add when you have ranges in here, then there is something called negate. This is the negation, and it's every bracket that starts with the what's called the hat symbol. So if you do, let's say the hat symbol, and I do A to Z lowercase, and then I have the circuit, but the difference in here is that you see this array of bytes. Please accept any byte except of any lowercase A to Z letters in here. So for example, if I give it a really huge list of inputs, but none of them contain this, it will return true. But if I have, for example, lowercase p, and it contained in this array, then it will reject it. So this is what's called negation in regex. And to sum it all, also with regex, if you want to use some things easier, it's called the meta characters, which is, as you can see here in the documentation, it's just a hard-coded set or like patterns to express a word. A word is like, for example, any alphabetic character, lower or uppercase, including underscore. And when it's uppercase, then you will have the negate of that, as I showed you now. And that's also, so for example, for numbers or like for space characters. So if I do, for example, /D, then I will have it expanded, as you can see here, 0 to 9, and I have the same circuit. And you can also abstract this with, I don't know, repetition, or like with any other. So I need any number followed by, for example, what's called ID, ID uppercase. So when I have a pattern like this, so any number and then ID. And the most powerful syntax is when you do the plus. So I think, yes, it worked. So if you have a plus in here, is that match one or more characters or digits and then follow it with the ID hardcode. So this is the one of the most powerful things to do with regex, is that I give it A to Z, for example, and then I follow it with the plus. And then what I say is also count if we want. We have, like, it says, please accept any, like, one or more sequence of the same AZ, for example. So maybe if anyone is familiar with regex in general, this says, for example, I can give you a pattern that's meaningful in this. It's like, this is what we, let's say this is a regex example. It's called name hard-coded with a column, and then I say it's like A to Z one time. So this will match only one uppercase alphabetic. And then I will have AZ plus, which is take one or more, and then finish it with a semicolon. This is like a name regex. And I just need to validate the pattern, so I don't need to count it. And I press enter, and I have the circuit. So what does the repetition pattern do is like, so this is our circuit with this pattern. Let me write you what's valid, for example. So first, everything should start with the name. And it's hard-coded. If anything is missing in here, it will fade. So if the semicolon is missing, it will fade. If the white space is missing, it will fade. And A to Z, it's like, accept any uppercase alphabetic. So I will write, for example, my name, Mahmoud. So it's like M. If you give it an M, lowercase, it will fade. So it's uppercase M, and then have a sequence, one or more, lowercase alphabetic characters. So I said, for example, my name is written like this, Mahmoud, and with a semicolon should be followed like this. So this is what is called the repetition pattern. It's like take one or more. So, and it's followed by the semicolon, which is also an anchor to that. So for example, in this, if I put the semicolon here, it will accept it till here, and the rest will be ignored. So this is how you can weave different regex pattern in with zkRegEx compiler. So this is a general presentation about the syntax with also the newly added features. So you can stop here a bit if you have any questions.
You're muted, Harish.
Sorry. My question was, does it support all regex operations you see, or is there like a subset of the operations which are supported by this compiler?
Yeah, so this compiler shows all of the supported operations with also the limitations that are not. So for example, if you are used to the anchor or like this asterisk, the cleaning star, 0 or more, or the optional, these are not accepted. But other than that, any pattern can be accepted.
Gotcha. And can those patterns be added and extended to the compiler, or are there like technical limitations which prevent them from being implemented?
Yeah, this is a very good question. So actually, the 0 or more and 0 optional, these are like with the zkRegEx with the deterministic nature, it's impossible to add these because you will have in the theory it's called one or more accepting states. That's not possible. But for example, with position anchors, laziness is theoretically not accepted for the deterministic nature of zk. But for example, these position anchors are can be added, and they are newly added to the Circon compiler, by the way. So with some effort, these can be added, by the way, the position anchors. And with that, you can say it's like 90% the similar syntax support of JavaScript regex, the casually used regex.
Awesome, thank you.
Okay, so this used to be a script. I can move like, because this used to be a script that used to be run like this. npm run zkRegEx, and then you give it a pattern. So this is completely removed now, and now it's a CLI that anyone can install. So, and as you can see here, the compiler shows everything. And by the way, it's much faster than a script because it's like directly a binary executed. There's no build or anything. So as I showed you here, it's quite impractical to copy paste, and like every time you need to, for example, like this name regex, enter, and then. So now regex gives you an option to write or append the circuit directly. So I can give a small pattern, so it's not take space. It's like this, for example. Yes. So this is a circuit. So first, I said like you have to give. We have an option in here. It's called function name. And what you can do is like, let's call it function name. Then you can add the argument. Let's call it name regex. Press enter, and then we have the circuit. But what's handled for you is like the export, the function name regex. So now if you copy paste this, I'm not using a mouse, so it's painful to copy paste anyway. Yes, so now this one. Yeah, now it can be like this. It can be fixed the code. Yes, it can be used easily like this. And this is, by the way, the compiler also registers the command as a command here. So you can, if you are using multiple ones or you want to recreate the command, then you have it as a comment. So this is not enough, but makes things easier. So the function name regex also binded to what's called the file path. And then if you give it, file path we are using is srcxp.ts, then if I give it .ts and I give it a different name, otherwise we'll have a duplicate name. So when I press enter, then look how amazing it is to have a secondly added regex like this. And by the way, we can delete the file. So we deleted the file. So now say it complains. What you can do is, if it's a new file, and then you give it a name, and you give it a path, and we press enter like this, then it will add the imports for you, and it will add the circuit directly. And now if I want to use the same path, it will append it. Now you have name regex too. So this is quite amazing. It makes using the compiler much easier. And with this, since the regex circuits are not generated runtime, I had to test every feature, and I used to copy paste every circuit, and I run the tests again. So with this feature, made it easier for me to adapt the updates. And I have a script like this, which will like run. You see, I'm running here 1, 2, 3, 4, 5, 6, 6 circuits in one script. And if I run a test in here, then it will be testing the newly updated circuits. So even like for development experience, or anyone want like to adapt the compiler or add anything, or have or to contribute open source, then yeah, it will make life easier like this. You can see have the MENA circuit as I showed, and have email regex. We have a negate regex and a simple regex. And this makes things easier. But you have to keep in mind that if you give a file path option without specifying a name, then the compiler will complain. Because if you add in here, like if you append it without a name, then it will be wrong, right? It will throw an error, or the TypeScript compiler will complain. Yes. So I have showed the reveal transitions. By the way, this used to be pretty difficult to do with the old script. What reveal is like going back. Yes, going back, for example, to this name regex. So what if I want to show to match the full pattern, but because this is anchoring to certain inputs, but I only want to fetch my name, and my name is represented in this pattern because it takes one uppercase and the sequence of lowercase characters. So this is what reveal does. So what reveal does is like you have two options: reveal transitions or reveal subpatterns. And what you can do is like reveal subpatterns, and then you just paste the pattern you want to reveal. And then if you press enter, you will have a longer new circuit. This is amazing because, and also as an input, it used to be pretty bad if you want to enter this in the compiler, because it will have to match the type. So let's say, what if you want to reveal something that doesn't exist? So let's say A to F. So the compiler will help you spot that, and it will throw an error. So you can only input the subpattern. This is why it's called the subpattern. And you can see here in the comments, this is related to the regex theory is called transitions. So what happens in here is that these sub-patterns are compiled to transitions, and it checks which transitions to reveal, and it's also shown here. But if you know what you are doing, then you can also do this with transitions. So we have the correctly ones. By the way, you have a cool, I think, it's you have a cool compiler web page like this, and you can also visualize the transitions in here. I won't do that here. I think I showed that last time, but I can show you how it works. So I'm now not revealing sub-patterns, but revealing transitions. By the way, you can do this if you are sure about transitions. I personally prefer transitions because they give me like a feeling of exactly which ones I want to reveal or expose. So if you give it an input like this, it will complain, but you will just remove the brackets and it will accept, like, this is called variadic. It's called a variadic option in Commander. So if I put enter, I will have the same circuit. And this is a newly added feature, also delivered as part of Navigator S2, is that it's a checker. Because before, if you add these transitions as numbers, the compiler will only add these like this. But this time, I think that opens the space for developers to make mistakes for the transitions they want to reveal. So we added the checkers that, let's say, 12. What if I input an incorrect transition or non-existent transition, and I put enter? Then I would have this error. This using this. So I said 2 to 12 is not found, but also chosen here that please make sure to input one of these transitions. So, and this is the list. So you have to make sure to have one of these transitions as input, and also like make sure to visualize this from the website, because that will give a meaning to what sub-pattern or like sub-transitions you want to reveal. So this is also works with what's called the collection of variadic options. That what if I want to separate? So I know this, by the way. It's called 2 to 2. So what if I want to expose only the first capital letter because I want to match that, and the rest? So I need to only expose 9 to 1, and I want to expose the full name. This is, and I press enter, and I will have a circuit that have 2 reveals. So say this is 0th and 1st. 0th only accepts the first uppercase letter of a name. This exposes the full name. So you have the flexibility to separate what you want to reveal or not. And we can, by the way, do this with sub-patterns. So we have just with a space, it's easy in here, is that, okay, just reveal the A to Z uppercase and the full name. We can add it in here. And expose. And we have exactly the same. 9 to 1, 9 to 1, 1 to 2, 2 to 2. This is a general idea on how the compiler works. Let me see if I have something more to show. Yes, so we have file path, function name, sub-patterns, transition, and count. Can stop here if you guys have any questions.
No, nothing from me, Carol. Do you have anything?
No, everything's clear.
Okay. So awesome. Yeah, if you have, so this is like really concise and general presentation of the compiler, but what I added in here is a proof of concept of how to operate on field elements. So, for example, I have this pattern. So, by the way, before I start, this is something that I was inspired with when I worked with the theory of regex and the nature of the circuits in here. And I said, okay, so the O1JS circuits take this type, for example, this type as an array byte. But the same compiler I had in mind can take full field elements. So why can't we operate on that? So imagine if we have a simple regex pattern like this: A, lowercase, we want to make sure, and then I want the count feature. So this in here will count the lowercase a inside of an array of bytes. But what if I want like to enter a full field elements and I want to count how many we have inside an array of field elements, not bytes? And also, like as I showed you before, like we have a, so for example, or like we have a sequence as like name, and we have a range of 0 to 9. All of this can be combined to operate on field elements, knowing the nature of the circuit. So if I said enter, I have this. So what I did is I tried to show this, and it's called field regex. So I have this fully documented in here, and I added, as I showed you in here, like an example on how that works. So imagine if we have this regex A to Z lowercase, or 1 or 2 or 3, but I want to prove that certain elements exist in a field array. So what I did is that I manually modified that in here. So this is the full circuit. It returns out as bool, which validates whether I changed the field elements in here, but I could make them generic. I could make them like inputs in here, like for example, A as field and B. I could change that, but I did hard code that. So what I said is that take an input, which is an array of fields, and if you have any value that is in this range, or exactly 19, or exactly 2024, or exactly -1. And -1 is the largest field for the proof system. So, and I manually did this in this circuit. So I can also show you the tests on how that works. It's called inclusion regex. So imagine I can give it a single element in here, and this will return true because it's 1, 2, 3, 4, 5, 6. It's larger, it's less than this, that's fine. And I could give it 19, it's true, the test pass, and 2024, -1, everything is unhandled. I give it only 1, which is not in any of these patterns, then it will reject it, it's false. And then you could give it a multiple elements. And if only one of these match, then it will return true. And in this case, we have 5, 6, 7, 8, 9, 10, 1. In this range, it will be true. And in this example, for example, like we don't have any element that's valid in this pattern, then it will return false. And to prove that this is correct, then. So this answers the question. I can walk you through more examples, but this answers the question is that how can you use zkRegEx? Then you can use it for text processing, for revealing certain subpatterns, for not only that, but for any provable type like field or uint8 or uint like 64. And with that, you can also handle that for conditional control flow. This is what I wanted to emphasize. So for example, you could do this manually, right? So you could have a range check for this, or a range check for 9, and then it's equals 19. So you could do this, but with a single command in zkRegEx, then you can have that directly without weaving that yourself. And by the way, this is a very simple example, but you can do everything you want, like I showed you, with negate, with repetition, with ranges, with like ORing. You can do any of that to handle field elements. So I can show you the next example. The next example So this inclusion regex is possible if you do it manually. But what about this one? So imagine we have a regex with this pattern. So I said zkr a b c d e, and I press enter, and we have this regex. What does this regex pattern mean? Is that please match if you have a sequence of these elements in a row, like in sequence. So what does that mean if it is in field elements? Is that imagine instead of A, B, C, D, E, I want to prove the sequence of field -1, -2, -3, -4, -5 in a sequence. What does that mean? An array that the sequence exists in an array. And if it is true, so it's true if the sequence exists. So imagine, like, how can you do this with normal O1JS code? Like, you have to, I think, to hard code the sequence, and you keep like scanning through the array to prove this. But it's only like one command away from that with regex. So I can show you how that works in the tests, which is quite amazing. So it's like, as I told you, -1, -2, -3, -4. So this sequence exists in this input. So we have a true here. And what if this sequence exists in a different position than this one, for example? Then it would return true also. And then what if I change just one element? So all of these elements exist, but in a different order. And what I did in this test, I switched -3 is -2. Then it's false, and the test passed. And then I reject that none of this exists. Then I will have like false, of course, because I have the sequence doesn't exist with any element. So this is a powerful way to use it also. I don't know if I have time to explain more, but you can do range count. So for example, this count in range regex, what it does is that I can show you maybe easier. So I chose this range with count. So it's like this. So for example, A to Z with plus, but I choose it with, of course, count. But I choose which range. So I chose this range, 5577, and it will count any element that's in this range from an array of fields. So for example, in this example, it returned 0 because none of these in the range, but in this example, it returned 5. So this looks simple, but it's very powerful. Lastly, it's called exclusion regex. As I explained, and negate, then you can validate or count if you want to certain element not to exist in this file. And this is what exclude regex. So going fast through the tests, I want to validate that these two field elements don't exist. And indeed, the tests show that if you have 100 random elements, and then I have only one in here, to return false. And to finish this, imagine these simple examples look this, but you can weave any like complicated or complex pattern with this operating on field elements. Yeah, that's all for my presentation. I'm open to any questions you have.
That thanks a lot, Mahmoud. I do have a question. It's regarding the sequence example you had shown. So let's say if I had an array which had elements 1, 2, 3, 4, 500, then 5, 6, 7. So is it possible
Yes.
for me to specify a sequence which kind of skips one element? So I can say I want 1, 2, 3, 4, any element, and then 5. Is it possible to craft something?
Yes.
A pattern like that? Okay.
Yes. I think if like in regex, so you will have something like this. So let's show it in string. So if you have, for example, hard-coded, right, sequence like A, B, C, D, right? And then I would say is like you want to escape, like you want something like a wildcard, I assume, right?
Yeah, it's like a single in any match for like maybe one element. Is that possible to do?
Yeah, actually, that's good. So maybe So you want to prove that. So for example, let's call it asterisk, right?
Mhm.
And then you want another sequence.
Okay, yeah.
So like this. Maybe that requires some manual because you see, you remember when I told you it's not possible to have the cleany star, which is 0 or more, right?
Mhm.
So the 0 state goes back to the accepting state. So this is not possible.
Okay.
Because of what I showed you in the limitations in here.
Mhm. All right, 0 or more patterns. I think
Yeah, exactly. Yeah, that's why. But for example, if I'm really want to do that, then what I do is the star will be accepted. So if I put enter, you will have the regex. What I can do is that I can have this and reveal only these two. So I can reveal this. I can reveal the first sequence and the second sequence and match that manually. That's possible with the reveal. So with the reveal, it would be like this. So S is for revealing subpattern, and if I do ABCD and ADFAD, then I can match these two. And maybe, I think it requires some work, but yeah, see, it's this. Now you have a different regex. I could say it's going towards no, because we don't have cleany stars, and cleany stars are known for wildcards, so I would say that's difficult.
Thank you. And I guess one general question is, what else would you like to add to this this project? Because I know we spoke and your vision was grander. So could you speak a little bit about that?
Yes. So I mean, what can be done in the future with this, right? Or how can it be expanded, if I understood right? So this was inspired by the Circom zkRegEx compiler, and they switched to Rust. Actually, it was maybe in the first stages in TypeScript. So, and it's very challenging to adapt that to O1.js because you have to deep knowledge in DFA theory to do that. What can be added to this project is that, inspired again from the zkRegEx Circom compilers, that they added those anchor syntax support, which is they had this position anchors added, which is awesome. And what they have also is that they got zkRegEx and Circom compiler audited by zk security, and they pointed to some small vulnerabilities, which is everything can be adapted to in parallel with O1.js. But those are for, let's say, more advanced cases. But yeah, I think there can be work done with the zkRegEx also in the future, and maybe also some research, because there can be some ways to optimize this more to be used for longer inputs. So I think maybe I should draft. Yeah, so I could show you, for example, so in terms of rows, this takes one field element and trying to do the inclusion regex, and it has 66 rows. And as I told you, in zkRegEx, if you use it 1024, let's say 1024. By the way, this is for fields, but if it is for bytes, it's more efficient. So you have, it's longer, it's 1000 times. So I think we have 66,000. Yeah, 67. So this exceeds the 64K constraint limit. So this circuit with 1000 elements cannot be You can't generate proofs for it. So if you have more optimizations so you can have this less, and you can also expand the usage case of zkRegEx. So yeah, there is some work to be added, but in general, the functionality is there. You can generate or compile any circuit you want, and also like with the zkRegEx compiler, it's very easy to use. And just to finish on what you asked is that, of course, the most perfect solution for this is to have these circuits combined at runtime, right? So imagine if you have generate regex circuit and you give it this AZ pattern and you have it used directly. That would be amazing. That's quite possible. Needs more research, but it also requires a lot of work, drastic reconstruction of the compiler, and that requires a lot of time and effort invested in it.
Cool. Awesome. Thank you, Mahmoud. Carol, do you have any questions? I think we have like 5 minutes.
Yeah, no, I think everyone is clear. It's impressive work, really great done. I think what you just mentioned at the very end, that having that in the runtime obviously will be the ideal example. But yeah, we all understand. I think it takes a long time to make that to work. But even from from the developer's experience, this is already something that for the particular cases that people use it, working amazingly. I'm really looking forward to potentially test it and use it, because I think the value there is incredible. So yeah, and that's all from me, really.
Yeah, thank you.
All right. So thank you very much, Mahmoud, for your time and this piece of work. And yeah, we hope to see more from zkRegEx in the future, hopefully. Thank you very much, and have a great day.
Yeah, thank you very much.
Bye. Thanks again.
Bye.
Bye-bye.